Greetings, Mr. Sutton, bringing you the Pre-Cal Honors 5-8 Part 2 homework solutions on simple trigonometric equations. For this problem, I'm going to start by isolating cotan. Add 5, divide by 4, 5/4. That's our cotan value. Can't really do much with cotan though. I need to get its reciprocal tangent, but to get the reciprocal and turn this into tangent, I have to flip the right side of the equation as well. So I can rewrite this as tan of theta equals 4/5. Now I notice that tan is positive on this. That tells me that my answers are going to be in the quadrants with positive slopes, so quadrant 1 and 3. Next, let's do inverse tan of 4/5 to get our reference angle. Plugging that in, I get 38.7 degrees. Now this happens to be a reference angle right off the bat without any kind of work. It also happens to be the quadrant 1 angle that we were anticipating. And now for quadrant 3, we have to do 180 plus 38.7. So that's going to be, let's see, 218.7 degrees. To get started on this problem, I notice first off that I have a trig expression isolated, which is good news. The bad news is it's not one that has an inverse button on the calculator. So to get one of my original 3 trig functions, I'm going to take the reciprocal of both sides. If I flip secant, I really just end up with cosine. That's the reciprocal of secant. And over here we'll have -1/5. So now that I've got one of the original 3 trig functions, I'm going to figure out what quadrants I'm in. Since cosine is negative, that means I'm to the left of the y-axis, so I'm in quadrants 2 and 3. Let me go ahead now and do inverse cosine of -1/5 to see what my calculator is going to give me for an angle. So second cosine, -1/5, plugging that in, gives me 101.5 degrees. Let's go ahead and get a reference angle out of this now. So we've got 180 minus 101.5, which is going to come out to, let's see, 78.5 degrees. So let's go ahead and use this to figure out quadrants 2 and 3. Now it so happens that we already have quadrant 2. The calculator gave us that. It was 101.5 degrees. For quadrant 3, we have to use our reference angle. It'll be 180 plus 78.5, which would be 258.5 degrees. On this problem, let me start by isolating cosecant. Dividing by 2, I have cosecant equals 3/2. And I really can't do much with cosecant, so I'm going to take the reciprocal to get one of the original 3 trig functions. Reciprocal of cosecant is sine, and now I need to also flip the other side of the equation to be 2/3 instead of 3/2. So we have sine equals 2/3. Since sine is positive on this problem, that means we're above the x-axis, so we're dealing with quadrants 1 and 2 after we get our reference angle. To get that, let's go ahead and do inverse sine of 2/3. So second sine 2/3 comes out to 41.8 degrees. Now that happens to be a reference angle right off the bat. It's between 0 and 90. And if we're looking for a quadrant 1 angle, this also happens to be a quadrant 1 angle. Next, we're going to find our quadrant 2 angle. So that's going to be 180 minus 41.8, which I'll do on the calculator. And that's going to come out to 138.2 degrees. To get to the bottom of this problem, I have to first isolate the tan function. So subtract 19, divide by 7, that's -19/7. Now I notice that tan is negative on this. That means I'm in the quadrants with negative slopes. That would be quadrants 2 and 4, where your angle is going down and to the right if you follow it. So 2 and 4. Let's go ahead now and do inverse tan of -19/7 to see what kind of angle our calculator spits out. So doing second tan, -19/7, I get -69.8 degrees. Let's get a reference angle out of that. This is only 69.8 degrees from the x-axis in the negative direction, so the reference angle is just going to be positive of that. Next, I wanted answers in quadrants 2 and 4. For quadrant 2, I need to do 180 minus 69.8, and that's going to be 110.2 degrees. Next, for quadrant 4, I need 360 minus 69.8. And let's see here, that's going to be 290.2. There we go. And I need to convert those to radians. So multiply by pi over 180 for each of these. Let's do this one first. So doing 110.2 times pi over 180 on the calc, we got 1.92 radians. And now let's multiply by pi over 180 down here. And just going back to my calculator, I'm just going to steal my input from earlier, and I'm just going to replace that original angle I had in there with 290.2, which is already there. Great. Multiply by pi over 180, we get 5.06 radians. For this problem, I need to start by isolating cotan, so I'll just divide both sides by 10 to do that. So we have cotan is negative 3/10, but there's no inverse cotan button on the calculator, so I need to convert this into tangent by taking the reciprocal of both sides. So the reciprocal of cotan, again, is tangent of theta, and on the right side we'll have negative 10 over 3, so just flipping both sides. So now I notice that I have a negative tangent. That means I'm in the quadrants where the angle is negative, quadrants 2 and 4. Let me go ahead now and take the inverse tan of negative 10/3 to get a starter angle here. So I'm doing second tan of negative 10/3 on my calculator. And I'm going to do this in degrees initially. I'm just going to convert to radians, which they want the answer in at the very end. So initially this comes out to negative 73.3 degrees. Now the reference angle on this is going to be positive 73.3. That's how far we are from the x-axis. And now I'm going to use my reference angle to get angles in quadrants 2 and 4. For quadrant 2, I have 180 minus 73.3, which is going to come out to 106.7 degrees. And then for quadrant 4, I need 360 minus 73.3, and I'll do that one on a calculator. And this is going to come out to 286.7 degrees. But now I'm not done. I have to actually convert these to radians. I'm going to multiply each of these by pi over 180. So we'll do this one first on the calculator now. So 106.7 times pi over 180 gives us 1.86 radians. And now I'm going to do the 286.7 times pi over 180. And if I go back to my calculator, I'm just going to grab my input from earlier, this 106.7 times pi over 180, because I can just replace the initial angle in degrees that I was using with 286.7. I've already got the 0.7 from before, so that's nice. Press enter. That's going to come out to 5.00 radians. We round off to the nearest hundredth. To solve this equation for an answer in radians like they've specified here, I'm first going to solve it in degrees and then convert to radians at the end. Let's start by isolating the sine function. So subtract 4, that's negative 2 on the right side. Divide that by 3. We have sine of theta equals negative 2/3. Since sine is negative on this one, that means I'm below the x-axis. So I'm dealing with quadrants 3 and 4. Let's go ahead now and do inverse sine of negative 2/3 to see what that comes out with. So second sine, negative 2 over 3. We get negative 41.8 degrees. Now I need to get a reference angle out of that. Reference angle is just going to be positive 41.8 degrees, because that's how far this is from the x-axis, just in the negative direction. Next, to get a quadrant 3 angle, I need to do 180 plus 41.8. So that comes out to 221.8 degrees. And now for a quadrant 4 angle, I need to do 360 minus this reference angle. So let's see, that's going to be 318.2 degrees. And I need to convert these to radians. So I'm going to multiply this first one by pi over 180. So plugging all that in, we get about 3.87, rounding off to the nearest hundredth. And now for this next one, again, multiply by pi over 180. And this time I'm just going to go back into my calculator and steal my input from earlier. And then I'm just going to change this initial angle to 318.2. And now I don't have to redo that fraction with the pi in it. So that comes out to 5.55, and that's also in radians.